Hey all, this is Guided Practice 3. This is from section 2.6 on limits and infinity. And we're going to jump right in here. If we take a look at number 1 and I think about plugging in my infinity to evaluate my limit. When I plug it into the cube, that's going to be infinity plus infinity minus 4, and that's going to be infinity. In the bottom, big positive numbers to powers, that's going to be infinity minus a smaller number plus 4, and that's going to give me infinity as well. So this is my infinity over infinity. So now I need to get rid of one of the leading powers. So I've got a 2x cubed and an x to the 5th, and I want to get rid of the smaller of the two powers. So I'm going to get rid of the x cubed. So that means I'm going to multiply top and bottom here by 1 over x cubed. That's going to give me the limit as x goes to infinity of 2x cubed over x cubed plus 7x over x cubed minus 4 over x cubed. In the denominator, we get x to the 5th over x cubed minus 2x squared over x cubed plus 4 over x cubed. From here, we want to simplify. Keep our limit notation. That becomes 2 plus 1 of the x's cancels in the middle, so 7 over x squared. And the last one doesn't reduce at all. In the bottom, x to the 5th over x cubed is x squared. 2 x's cancel in the middle term, so 2 over x. And 4 over x cubed in the last term. By the way, these two do not cancel, even though they're sitting right there. They're tied using addition and subtraction to something else. From here, we're going to go ahead and evaluate our limits. We're going to plug in that infinity. All right, once we've done that, we know that all of these fractions are going to go to 0. And we're going to be left with 2 divided by infinity, and 2 cookies shared with everyone in the world is still 0. Okay, now maybe you can start to make some connections and guesses about when we're going to get which type of answer, but we'll hold on to that for the next class. Okay, next we've got this one. And again, if we plug in, we're going to get infinity over infinity. And what we want to do is we've got a leading power of 4 in both places. So I know what I'm going to multiply by 1 over x to the 4th, top and bottom. And that's going to give me the limit as x goes to infinity, 4x to the 4th over x to the 4th minus 1 over x to the 4th. And in the bottom, 7x to the 4th over x to the 4th plus 3x squared over x to the 4th plus 1 over x to the 4th. Now I want to reduce, so this becomes the limit as x goes to infinity of 4 minus 1 over x to the 4th, 7 plus 3 over x squared plus 1 over x to the 4th. Again, those last two terms do not cancel top and bottom. They're being tied together with addition and subtraction. So that means we can go ahead and plug in our infinity. So that gives me 4 minus 1 over infinity, 7 plus 3 over infinity, plus 1 over infinity. All of these numbers divided by infinity are 0. And I end up with 4 over 7. And our last one. Again, this one's also going to give you infinity over infinity. So I want to clear one of those leading terms. I've got an x to the 4th and an x cubed. I'm going to go with the x cubed. Right? You can use the top one, but sometimes it's a little bit funky in terms of the answer that you get. If you go with the smaller of the two, it will always work out kind of nicely for you. Okay, and by the way, if you don't multiply by enough and you get infinity over infinity when you plug in at the end, means you got to divide through again by whatever the leading term is. The objective is for one of these to not have x's. Okay, if we go ahead and distribute that, that's the limit as x goes to infinity. 4x to the 4th over x cubed, 2x squared over x cubed, and 1 over x cubed. On the bottom, 3x cubed over x cubed, 7x over x cubed, and minus 12 over x cubed. From here, we can go ahead and simplify. Keep our good notation. All right, I'm left with a 4x in that first term. a 2 over x in the second term, and a 1 over x cubed. In the denominator, the x cubes cancel, and I get just a 3, plus 7 over x squared, and 12 over x cubed. Now I can go ahead and plug in my limit. So 4 times infinity is infinity. And then we have 2 over infinity plus 1 over infinity. 3 plus 7 over infinity minus 12 over infinity. And again, all of these numbers over infinity are all going to go to 0. If you have a small number of cookies divided by everyone in the world, that's no one gets a cookie. And you get infinity divided by 3, which is still just infinity. Okay. Now that we can justify it using algebra, when we move into the next section and we can start using shortcuts, think about what happens here. When we had x to the 4th over an x cubed, we ended up with infinity. When we had x to the 4th over x fourth, we had 4/7. And when we had an x cubed over an x to the 5th, it was 0. So what we can start to do is to make some shortcut rules about what our answer is going to be based on what those powers are. And you can tell right away when you have more on the bottom, it's 0. When they're balanced, it's the number in front of your leading coefficients. And when you have more stuff or more power on the numerator, it ends up going off to positive or negative infinity. And the way that you can tell which one it goes to, positive or negative infinity, you can kind of simplify this down and make it the limit as x goes to infinity of just those 2 leading terms. So 4x to the 4th over 3x cubed. And if you reduce that, that's the limit as x goes to infinity of 4/3 x. And when you plug in your infinity, that's just 4/3 times infinity, which is just infinity. Okay, so that's kind of a shortcut way to determine what your answer should be. But when you're asked to create your answer, justify using algebra, I want you to show what you're multiplying by and give me all this good stuff here on the left. Okay.